And back with, excuse me, 3502 for our investments course. Now we're taking a look at finishing from chapter 6, question number 7b. Let's make our screen full size. That aside, and papers. So in question 6, we were first given some information. Stocks are expected to have a return of 20% with a standard deviation of 0.3. Bonds are expected to have a return of 12%, standard deviation of 0.15. The correlation between the two is 0.10. So in part A of question 7, we solved for the weights of the optimal portfolios, and we determined the weights for stocks should be 45.16%, and the weight for debt or bonds would be 1 minus the weight for stocks, so 1 minus 0.4516 was 0.5484, or 54.87%. 54.84%. Okay, and those total 1 easily. Now, the next piece for B was asking for the risk. What page do we have this? On an optimal risky portfolio, after we found the preferred weights, what would be the weight of return and the standard deviation to the portfolio. And that takes us to page 201 of our textbook. Okay. Our weights, so the expected return on the portfolio is, let's shift this around to what our textbook used for formulas. Weight of debt times expected return for debt plus weight of equity times, for convention, expected return on equity. And we could put this down. The weight of debt, 0.5484. Expected return on debt, 0.12. The weight of equity, 0.4516 times expected return on equity, 0.20. So that we can start to solve this, work through this. 0.5484 times 0.12 is 0.0658, and 0.4516 times 0.2 is 0.090, or 0.0903. Coming back, adding to that 0.0658, our expected return is 0.1561, or 15.61% return on a blended portfolio. Okay. Second piece asked, what's the standard deviation on our new portfolio that we've constructed? So for this, the bottom of page 201, the standard deviation of the portfolio is going to be the weight of each component, so we'll use debt first, times variance, or standard deviation squared, plus weight of equity squared times its variance, so the standard deviation squared. Now something a little different, plus 2 times weight of debt times weight of equity times covariance between debt and equity. Covariance. we know the correlation because that's been given to us. We can remember covariance is rho times standard deviation debt, standard deviation of equity, or rho times standard deviation of one asset and standard deviation of the other asset. This is 0.1 times 0. If we put debt first, 1.5 times 0.3. So 0.1 times 0.15 times 0.3 is 0.0045. And that number we drop down to the formula. Remembering now, close this off, and because we want standard deviation, everything in the brackets is the variance. Putting numbers to this, weight of debt 0.5484 squared times our variance or standard deviation squared for the bonds, the debt portfolio, plus weight of equity 0.4516 0.4516 squared times standard deviation for equity squared plus, come back down, 2 times 0.5484 times 0.4516 times covariance 0.0045. Remember, this is all part of a formula, so close that and the 1/2. Okay, so now a small bit of calculation. You can see this. 0.5484 squared is 0.3007. 0.15 squared, we remember, is 0.0225, so 0.15 squared. 0.5416 squared and 0.3 squared is 0.09. And then plus, let's work through this last piece to solve it. 2 times 0.5484 times 0.4516 times 0.0045 is 0.0022. Okay. However, all of that is variance, so again to the 1/2. So 0.3007 times 0.0225, 0.006, say 68, plus 0.2039 times 0.09, 0.01835 plus 0.0022 to the 1/2, 0.0068 plus 0.01835 plus 0.0022 gives us 0.02735 to the 1/2. So our square root of this is 0.1654 or 16.54%. And let's check this with the textbook answer sheets. Quickly. This was question 7 from chapter 6, finding an optimal portfolio. That doesn't want to work quickly. Yes, there we have it. So our answer sheet tells us the expected return is 15.61%, and the standard deviation 16.54%. So we have a couple of observations to make too. By combining, this is our combined then optimal portfolio, we've increased the return well over what the bonds were going to be, our least risky item, and we haven't measurably increased the risk of the portfolio. So 16.54, not much higher than the standard deviation on bonds, but the return is significantly better. So this is our part of our portfolio theory now. The diversification of the asset can increase the return or improve the risk profile. And that shows for question 7, parts A and B. So the entire purpose of the question is calculating optimal weights for a risky portfolio.